This video covers the last new rule for proofs in QL, quantifier negation. So we've made the proof system for QL by taking all of the rules from SL and adding 4 new basic rules, an introduction and an elimination rule for each of the quantifiers. Now we're going to add one new derived rule, a replacement rule called quantifier negation, which we'll abbreviate QN. When we were translating from English into QL, we learned that the sentence, "Nobody is happy," could be translated 2 different ways. With a universal quantifier, we could write for all x, not hx. With an existential quantifier, we could write not exists x, hx. These were both correct answers because they're logically equivalent. In terms of proofs, the claim that these are equivalent amounts to the claim that given one of them, you can prove the other one. So given not for all x hx, you can prove exists x not hx, and given exists x not hx, you can prove not for all x hx. These can be shown with just the basic rules, but they're fairly complicated proofs. Note that the sentence, "Not everyone is happy," also had 2 possible translations. We could write not for all x hx, or exists x not hx. And again, these are both correct answers, and they're logically equivalent. That equivalence again amounts to 2 possible proofs. If you assume one, you can prove the other. We're not going to do those proofs because they're long and kind of ugly. One of them's done in the book if you want to take a look. In the proof system for QL, we add a replacement rule, quantifier negation, that lets us take advantage of these equivalences. You can rewrite a sentence with one quantifier as a sentence using the other quantifier by moving the negation across it. So if you have one of the 2 translations that we were looking at earlier, you can get the other one by quantifier negation. Here's an example. Suppose we're asked to show, given not exists x, cx, or dx, that we can prove not dA. There are a number of ways to do this proof, but here's one of them. You might look at the premise, line 1, and think, that's not really very useful, but I can apply quantifier negation to it and turn it into something else. If we apply quantifier negation to line 1, we get for all x, not cx or dx. That's the rule is quantifier negation applied to line 1. Now, line 2 is something we can do more with. Because it's a universal sentence, we can think about applying universal elimination. That lets us drop the universal quantifier and replace the variable with a constant. We could pick any constant we want. But a natural choice would be A. It seems promising because we eventually want not dA. So we can write down not, parenthesis, CA or DA, close parenthesis, by universal elimination applied to line 2. So line 3 is the negation of a disjunction. On its own, hard to work with. But when you see that pattern, it should trigger a kind of reflex. Now, if you're not sure, think about pausing the video, look at the rules of proof, think what could apply. When you see something like line 3, you should think, maybe apply De Morgan's rule. It's a negated disjunction, and you can turn that into a conjunction of negations. It's not always going to be the best move, but it's often useful because it turns something that's hard to deal with, like line 3, into something that is easier to work with. We can write down not CA and not DA by De Morgan applied to line 3. Now, line 4 is a conjunction. And the conjunction elimination rule lets us write down either conjunct. That is, we can just write down not dA by and elimination applied to line 4. Not dA is what we wanted, so we're done. So that's it. Now we have the complete proof system for QL. I realize that proofs in these videos go by quickly, but I don't expect you to be able to put together proofs this fast. Constructing proofs is a matter of trial and error, so you need to try things. Some of them won't work out. When you wonder whether a rule will apply or how a rule could apply, there's a reference sheet for that. You should have the reference sheet handy and use it as you're building up proofs. So if you didn't think of De Morgan's rule in the proof we were looking at a minute ago, you can look at that sentence and then look over the page of proofs and see what patterns are there here that would allow me to do something. And you might recognize the pattern from the sentence in the proof as the pattern fitting De Morgan's rule. So make use of the reference sheet. Try things out. It takes practice.